Okay, class to Alpha, a very good morning to you. Can you hear my voice? Sound
Yeah.
testing? Okay, thank you for your reply. And I hope others also can hear my voice loud and clear, yeah? Who are you? Okay, thank you. Thank you for your response. And then my presentation, can you see as well?
Can.
Okay, very good. Thank you very much. Right. So we continue our lesson for today. I hope you are all in a good condition today. Um, if you look at the latest news yesterday, how many new cases for COVID-19? How
Six,
many?
6,000.
6,000.
6,000.
Yes, of course, 6,000 something. It's very shocking. And then I think lah, we just sharing the thought only. I just discuss this matter only. Nothing. Um, uh, I don't know lah. Maybe for the next few days, the numbers will go up lah, like rocket. Yesterday 6,000 something. Perak also yesterday is about 220 positive cases, and in Sugarciput in Kuala Kangsar we have how many in Kuala Kangsar is maybe about one or two cases lah, but in Sugarciput, in Kuala Kangsar it's still under control lah, still manageable, but others area like Ipoh, so many people are already infected. And then there are new what we call new variant, new strain of COVID, spreading in Malaysia right now. I don't know lah whether it is from Africa variant, Indian variant. I don't know. And then this new COVID virus, if people infected with the COVID virus, maybe when they do the testing for the virus, they will come out negative. Okay, and then there is no symptom, especially for the younger people, like younger people, there is no symptom. The old variant, they got fever, and then maybe they have coughing, and then they have a sore throat. But the latest one, I don't know lah, very fast spreading. So I hope you guys can stay at home lah. Stay at home if you have nothing important to do outside. It is better for you. Advisable to you to suggest to you to just stay at home, and then maybe if you really go out, please what we call follow the SOP lah, wear the mask, and then practice hygiene at all times. Okay, this is very important. And then me myself, this Raya also I just stay at home only. There is no visiting the friend. No, just stay at home and then stay safe. Because we do not know because of the COVID. People who have COVID, the new variant of the virus right now, people who are infected does not show any symptom. That is very worrying. What we call worry for us lah. Doesn't show any symptom, but they can spread the disease. Okay. Okay, never mind. I don't know. We just look to the figure. How many positive? So just be careful and then follow the SOP, right? Okay, right. So can we continue the topic for today? I think this is the last topic. Can you see the presentation? I hope you can see my presentation. Yeah.
Can.
Okay, very good. Right. So this is the second topic in chapter number 6. Right. This is the second topic, and then the last subtopic for chapter 6. Yeah. We call it neutralization. Okay. You call it neutralization. From the word what, class? You can also refer to your textbook later on, page 132. Sorry, 133. And then yesterday also I asked you to read the chapter first in order to get more understanding about the topic, right? So 6.2, page 133, neutralization. So If you look at the word here, from the word what? From the word what, class? It is originally, the original word is neutral, isn't it? Can you see it? Hello?
Yes.
Yeah, from the word neutral, right? Okay, when you see the word neutral, what come up to your mind? Neutral. Neutral mean what? Anybody can give me an idea? Neutral mean?
Between acid and alkali.
Okay, very good. Thank you for your response. Meaning that the properties of the substance is neither acid or alkaline. Okay, it is not acidic, it is not base, or it is not alkaline. Okay, so this is neutral. And then second question, if I ask you what is the value of neutral, pH value of neutral, anybody?
7.
7. Okay, very good. All right. So neutral is either what we call is neither acid or alkaline. Okay. So how we can get a neutral solution or neutral substance? Usually, if we mix between acid and alkali with a right quantity, right quantity on both acid and alkali, it will become neutral. Okay, this is what happened when we mix these two substances, right? Mix with alkali, the acid mix with alkali, but with a correct substance. For example, here, if you want to right quantity and then right concentration, we already learned about the concentration, right? There are dilute solution. You still remember dilute solution, and then we have concentrated solution, and then we have saturated solution. Okay, not just we need to have a what we call same volume, same quantity, but also we need to have the same concentration of solution in order to achieve neutralization when we add acid and alkali together. Okay, can you understand this? All right. So what happened when you put acid and alkali? What is the word equation? You must remember this word equation over here. When we put acid, we mix acid and alkali, and then it will turn into salt and water. Okay, this word equation or the reaction that you need to know is like this. Okay, can you understand this? If you put acid and alkali, it will turn salt and water. Okay, and then salt and water is usually what? Salt and water is usually what we call by what is the type of the solution? Salt and water. It is neutral. This is new NEU neutral. Neutral. This is neutral. Okay, right. So what is the reaction called? This is called the process when you mix alkali and acid together, we call it neutralization. We call it neutralization. Neutralization. So what happened during the neutralization? Acid lost its acidity, and then alkali lost its alkalinity. Okay, meaning that the characteristic that you have already learned in 6.1, for example, the taste of acid sour, right? It also lost its characteristic. Okay, when it's mixed with alkali. For example, bitter taste of the alkaline when you mix into the sour taste of acid, it will lose both taste. Okay, and then it will become what? It will become salty. Okay, and it will become neutral, right? So that is the what happened during neutralization. And then number 3, What is the method what is the method or what is the way to perform neutralization? We call it titration. Titration. Can you see the word titration? This word there, titration, right? Titration. Okay. Titration is the method of neutralization. You just remember this, okay? Because we are playing with words and terms here. Yeah? Make sure you understand the terms, the meaning of the terms, and then what happened, what is happening in those terms. Okay. Again, neutralization is the process of what? um, Acid lost its acidity and alkali lost its alkalinity. And then number two, you must remember what happened during the neutralization, acid plus alkali, and it will become salt and water. And then what is the method number three? Number three, the method is what we call titration. Titration. Okay, can you understand this? Any question before I continue?
No.
Okay, good. I hope others also give the response. Yeah. Okay. Either using the chat button also can, right? Okay. So number two, next one, different acid. If you see here, different acid and alkali produce different salt. Okay. So this is the common acid and the common alkali that we usually found in the lab. Okay, like I said yesterday, there are many type of acid, there are many type of alkali, but in form 2, yeah, this is the common acid and alkali you need to know. Number one, what is number one? Number one is hydrochloric acid. Number two is sulfuric acid, and then number three is nitric acid. Okay, this is all the common acid we can found in the lab. Okay, hydrochloric, sulfuric, and nitric. Okay, and then what about the type of alkaline we usually found in the lab? Okay, usually if the last word, the last name of the solution is hydroxide. For example, this one, hydroxide. This one, potassium hydroxide, and then sodium hydroxide. Usually, when the chemical name, the last name of the chemical is hydroxide, usually it is a alkali. You just remember that. Can you understand this? Can you understand this common acid and alkali?
Can.
Okay. Hydrochloric acid, very simple lah, because the name itself show the word acid, right? No problem. But alkali, hydroxide. The last name of the chemical name is hydroxide. So if you found the name hydroxide, meaning that it is alkali, right? Okay. For example over here, when you mix hydrochloric acid with sodium hydroxide, what will happen? It will turn into salt, all right? It will turn into salt, and then what is the name of the salt? The name of the salt is sodium chloride, plus another one, plus water. Okay, every reaction when you mix acid and alkali will produce water. Okay, will produce water. Please do not confuse with the previous topic. Previous topic, when you mix what? When you put metal inside acid. Okay. If you want to previous topic, we want to study the characteristic of acid and alkali. Previous topic, when you put metal into acid, it will turn what? Anybody? Can you still remember our previous lesson yesterday? When you put metal into acid, what will happen? It will produce what? Yesterday. It will produce also salt and what? Yesterday. Anybody? You can refer to your workbook because we already discussed this yesterday. Yeah. Metal and acid will become salt and hydrogen. Okay. This is when you mix metal with acid. But today, when you mix acid and alkali, it will also become salt and then not hydrogen. Yeah? It will turn salt and water. Okay, do not confuse with this two-word equation. This two-word equation is very, do not confuse with these two. Yesterday, metal and acid. Today, acid and alkali. Right? Right. So, sodium will become, hydroxide will become chloride. Potassium will become sulfuric acid plus potassium hydroxide will become potassium sulfate, and then nitric acid plus sodium hydroxide will become sodium nitrate, and will become sodium nitrate. Okay, you just take the word over here and then you put in front. Sodium will become sodium, and then nitric will become nitrate. Okay, this is the word equation for neutralization. The word equation for neutralization. Okay. Any problem? Any question?
No.
Okay. Right. So next one, this is the method of what we call titration. This is titration. Maybe after the school will open, we try to do this, right? Okay. Anybody want to come in? All right. Good. So, this is the method of titration. Remember, titration is the method, and then titration is the method for neutralization. Right? If you look at the picture here, this is how you set up the titration method in order to do neutralization. All right, you have here without stem, we have conical flask, and then you have also burette, and you put hydrochloric acid in the burette, and then you put what we call sodium hydroxide in the conical flask here. Okay, I will try to search for the video. I hope the internet is okay today because yesterday cannot show the YouTube. Maybe we can do after the school open. Yeah, we try to show you what is the titration method. Yeah. Okay. Can you see the video over here? Right? Can you see it?
Can.
Okay. So this is the method of titration. We use what is this? Apparatus. Okay. What is the teacher's holding? What is that apparatus? We call it
Burette.
burette. Okay. And then at the bottom of the burette, we have a valve here. Yeah. This is the valve to channel all the content inside the burette into the conical flask. Right. Okay. And then first, you need to clean the burette first. Right? Clean it first, and then you put acid. Okay, can you see the valve here? You want to channel the valve into the beaker or into the conical flask. You need to wash it first, lah. Clean again. They just the teachers they are clean the they clean the burette first, right? And then they clamp it into the retort stand. And then they put conical flask at the bottom of the retort stand. And then they close the valve. And then they put this one, they put what? The teacher put acid, and then make sure there is no bubble. Okay. Just clean it first. Clean the conical flask first, and then you take the first measurement. Okay, first measurement. Okay, you record from the bottom of the meniscus. Okay, initial volume is about 6.88 milliliter. Okay, what is this device, class? What is this apparatus? You still remember in Form 1? The device, this is burette, right? What X is burette, and then Y is?
Pipette.
Pipette, okay? Okay, very good. X is burette, Y is pipette. And then if you still remember, the pipette measure exactly how much volume?
25.
25 milliliter. Thank you very much. Okay, correct, right? Pipette will measure exact volume of 25 milliliter of solution, right? Okay. Then they put indicator here. Maybe you can put what type of indicator? Maybe you can put universal indicator, or maybe you can put phenolphthalein indicator into the conical flask with 25 milliliter of alkali. Then you put, okay. Okay, class. Why the teachers put white paper at the bottom of the conical flask? Why do you think they put the white paper there? Because what? To observe what? You need to observe the, hello? Can you hear me?
Can.
Okay. Why the teacher put the white paper at the bottom of the conical flask? Okay. I just reverse it a bit. Okay. I just reverse. Just wait. Okay. This stage over here, after the teacher put 25 milliliter of alkali inside the conical flask, they put an indicator here. What is the indicator here? Maybe they put what? According to the textbook, they put phenolphthalein. You still remember phenolphthalein? You still remember phenolphthalein? What happened when they put phenolphthalein in alkali? Got color or no color? If alkali, what is the color? If neutral, what is the color of phenolphthalein? What is the color of the solution here? Okay, you can refer back to your textbook. Never mind, I will try to refer back to the textbook over here. Okay. Where is the textbook? Okay. Indicator. Where is the indicator? Where is the indicator? Sorry. This one. This one, eh? Okay, phenolphthalein, when phenolphthalein, yeah, 260. Okay, number one, phenolphthalein over here, phenolphthalein, this one, indicator. If you put into alkaline solution, it will become, what's the color of the solution? If you put phenolphthalein inside alkali, it will become pink, or it will become purple, purplish. All right. So when it become neutral, the color change to what? The color change to colorless. Can you understand this? Alkali, pink. Neutral, it will become colorless. Okay, you can understand this, right? This is the indicator to show whether the solution is alkali or neutral. All right. So you go back to the picture over here. Go back to the video. Why the teacher put white paper at the bottom of the flask? Okay. Now the acid over here, I will show you again. The acid here is not put inside the conical flask yet, but inside the conical flask we have we have the alkali. We have the alkali plus phenol. What is the name? Phenolphthalein. We have alkali and phenolphthalein. And then what is the color of the alkali inside here? What's the color? Alkali plus phenolphthalein. What's the color, class? What's the color?
Pink.
Pink color. Pink color. All right. Okay. So you must remember, this is method of titration. We want to get the alkali to become what? We need to get the alkali here to become what? What's the process?
Neutralization.
Neutralization. So we need to neutralize the alkali inside here. And then what happened? How we know that the alkali become neutral?
Become pink.
Become pink or become what? Again, become pink or become what? It will become this one. This one.
Oh, colorless.
Yes, it will become colorless. At first, when you put phenolphthalein inside the alkali, it will become pink. And then when the solution become neutral, it will become colorless. That's why that's why the teacher here put the white paper here, because the teacher want to observe whether the solution there become colorless or not. And then what happened if the if the solution here become colorless? So you need to stop the acid from coming in because it's already neutral. Okay, again, I will show you. All right. So we continue. Okay, mix around the alkali and then you open the valve and then put the acid inside the alkali. Okay, until it become what? Until it become, I think in this condition, sorry. In this situation, yeah, there is acid inside the conical flask and then alkali inside the burette. Yeah? You can use either one. Whether you put alkali inside the burette or acid alkali inside the conical flask is same. Sama saja. Can you understand this? Okay. Sorry. In this experiment, what inside the conical flask? Sorry, class. Okay, again, I'm very, very sorry. Inside the conical flask, acid or alkali? flask. Okay, never mind. Inside the conical flask is acid. Okay, inside the burette is alkali. That's why I noticed, sorry class, I'm very sorry. That's why I noticed when the teacher put the phenolphthalein inside the conical flask, got color change or no? Got color change or no here?
No.
No color change right here, right? No color change meaning that it is,
Neutral.
okay, again, sorry. Meaning that it is acid, sorry. Colorless also acid. Can you understand me?
Can.
Okay. Right, never mind. Okay, never mind. I think we need to do this experiment later when we go to come to school, because in order to further understand the situation. Without just explaining like this, maybe got some confusion here. Okay, but never mind. I just show you the titration method first, right? Okay, you just watch the video first. It's become okay, and then you take the final measurement, the final volume, and then how many alkali or acid you put inside the conical flask. Okay. So this is a titration method. Just to show you, this is the titration method. Okay, maybe after the school, when the school reopen, we can do this experiment. Okay, no problem. Right. So again, okay, last one. All right, application of neutralization in daily life. I think you can read it for yourself, but I will give you some keyword here. All right, when you do brush your teeth also, the process of neutralization, because inside our mouth is acidic, and then when you use when you brush your teeth with the toothpaste is usually alkali. Then when acid mixed with alkali, so it will become neutral inside your mouth. Okay. And then the shampoo, right? You still remember yesterday our skin is about 5.5, a little bit acidic, right? And then our scalp here, hair also a little bit of acidic. So you need to use the shampoo that is alkali to neutralize the acidic properties of our skin and hair here, right? That's what, but we cannot use shampoo daily lah, yeah? Maybe about 2 or 3 times, 2 or 3 days at a time, right? Okay, and then acidic soil can be treated with slaked lime. Slaked lime is alkali, and then also fabric softener are acidic, and then they reduce the pH level of fabric, and then watch with detergent. Okay, this is, I think you can read the application of the acid and alkali neutralization in our daily life. Okay. Any question?
No.
Okay, if there is no question, I hope you understand. But if you do have a question, you can ask me any time. Okay. For your exercise for today, uh, you do formative practice 6.2 on your textbook. And then for your workbook, I think I will skip page 70. Huh? Page 70, I think I will try to show this activity when you all come back to school. And then, okay, you finish page 71, 72, 73, 71 to 73 on your workbook. Okay, right. Is there any question anymore you want to ask?
No.
No
No.
question. Okay, all right, good. So I will just close this. Okay, I think I will stop here. So we'll be meeting you again when? When is our next class? I think next week, right? Is it next week? Okay, so our next class is on Monday next week. So see you all again next week on Monday at 12:30 in afternoon. Okay, and then of course, if you have any question, you can ask me on the Telegram group as well. Okay, I think we stop here. You can leave the class. Thank you for your cooperation and listening. Please do the exercise that I gave you just now. Thank you very much. Bye bye. See you again next week.
Thank
Bye.
you, teacher.
Bye bye. Thank you, Intum.
Thank you, teacher.
Thank you. Thank you. Thank you, Xuan Wai Xuan Yang.